real solutions. We make the math real for you. This week's topic is calculating the square root of 2 without a calculator. Before we begin, I want to review rational and irrational numbers. Rational numbers can be represented as a fraction, and they're also going to be repeating or terminating decimals. Irrational numbers have never-ending decimals that do not have a pattern. So when we're considering calculating the square root of 2 by hand, we're going to be working with a decimal that doesn't have a pattern, which means the work, there's going to be a lot of it. But I didn't say it was going to be easy. So let's look at rational and irrational square roots. Rational square roots are basically the square root of what's called a perfect square. And if you're wondering what's a perfect square, well, it's that, a perfect square. So in this case, we have the square 9. 9 is a square because it can be made by 3 by 3. 3 times 3 is 9, making 9 a perfect square. If we take the square root of the perfect square, 9, we're saying, if given a block of 9 squares, what is the side length? Well, we know that it's a 3 by 3. That means that the square root of 9 equals 3. Because 3 times 3 is 9. You can also consider other ones like 4. The square root of 4 is 2 because a 2 by 2 makes 4. Then we have irrational square roots. Well, they're basically the square root of all the other numbers that are not perfect squares. For example, 2. 2 is 1 by 2. We can't rearrange the squares to create a perfect square, leaving the square root of 2 to be irrational. We just can't estimate it easily by hand. And it's never going to be a nice, pretty, perfect whole number like all the perfect square roots. We can also consider 3, which is almost a perfect square. And you're like, oh, if it just had another block, then it would be 4, but then 4 is a perfect square. So 3 is also an irrational square root. So the square root of 3, we can't get the exact value of it, but we can estimate it with a lot of work. So now that we've covered rational and irrational square roots, we now know that the square root of 2 is irrational. And let's calculate the square root of 2. So let's start with the process. I could type it out for you, but in this situation, it's way easier to show you. Now, before we get started with the number line, I want to introduce this word radicand. So if I ever use the word radicand, it's just referring to the number that's underneath the radical symbol. So if I refer to 2 as the radicand, the square root of 2 is what I'm talking about. Okay, so number line. We have a traditional number line, let's say 1 to 16. Numbers on the left are small, numbers on the right are bigger. But I'm going to go ahead and look at these as square root number lines. So I'm just going to square root every number on the number line. The rule still follows. The square root of 1 is going to be less than the square root of 16. So you're thinking, how is a number line going to help me estimate the square root of 2? It doesn't tell me the exact value. I'm just plotting it on the number line. Well, it's much easier to start estimating when you narrow your window. So let's look at just our perfect square roots. We can kind of compare now. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. I can see that the square root of 2 falls between 1 and 2. So there's my estimation window. I've now cut out all of the other numbers and I've focused in on just between 1 and 2. This is going to help us get started, and it's the beginning of our process. So let's take a closer look. We know we're between 1 and 2. But which one is closer? So for this, it's easy because we can look at this halfway point. That's 1.5. The square root of 2 is on the left of the halfway mark. So that means that the square root of 2 is closer to 1. So we know that the square root of 2 is between 1 and 2, which means that 2, the radicands, are between 2 and 4. 2 is closer to 1, which we can already see here. It's on the left side of the halfway mark, so we're looking at just between 1 and 1.5. That's our estimation. So I only need to look at the values 1, 1.1, 1.2, 1.3, 1.4, 1.5. And I need to figure out, okay, now which one of those values is the square root of 2 between? But I don't know what the square root of 2 is, so I have to compare the radicand. So I have to compare 2 to the square of all these numbers. So next step is square everything. 1 squared is 1. 1.1 squared is like 11 squared, so it's 121, but it's 1.1, so it's 1.21. 12, 144, so it's 1.44. 13, 169, so it's 1.69. 14 is 196, so it's 1.96. And 15 is 225, 2.25. So now I can see that I'm between 1.96 and 2.25. 2 falls, the radicand 2 falls between 1.96 and 2.25. I've now narrowed it from between 1 and 2 to just between 1.4 and 1.5. This is great. Now we can keep going and take a closer look. So now I'm going to do the same thing again. I'm between 1.4 and 1.5, but which one is closer? I'm going to need to do some subtraction here and see which one is closer. So I've got 2.25 minus 2 is 0.25. So that means 2 is 0.25 away from 2.25. And then I have to do, well, we'll do 2, subtraction the other way, minus 1.96. Got to do our borrowing. And I get 0.04. So if the square root of 2 is between 1.4 and 1.5, then 2 is going to be between 1.96 and 2.25. And we now know that it's closer to 1.96, therefore it is closer to 1.4. So I'm only going to look between 1.4 and halfway. So I'm going to start with 1.4. Then I'm going to do 1.41, 1.42, 1.43, 1.44, and 1.45. Again, I don't know what the square root of 2 is, so I have to compare the radicand, which means I need to go through and square all of these values to get the radicand value. So let's start. Wow, that was fast. There's no need to square the other decimals when I've already reached a number greater than 2. So I know that 2 is between 1.9881 and 2.0164. That means that the window that we're looking through now is between 1.41 and 1.42. So we know that the square root of 2 is going to be 1.41 something. So now we're going to take an even closer look. So now I'm looking between 1.41 and 1.42. So between 1.41 and 1.42. And I'm trying to see which one is closer, 1.9881 or 2.0164. And we're going to subtract again. We can see that the square root of 2 is going to be closer to 1.9881, which means that it's going to be closer to 1.41. So we're now looking between 1.41 and the halfway mark between 1.41 and 1.42. So we start with 1.41 and we do 1.411, 1.412, 1.413, 1.414, 1.415. Again, we're comparing the radicand values, not the square root of 2 because we don't know what it is. We have to square everything. Let's begin. So we can see the radicand value of 2 falls between 1.999396 and 2.002225. That means that the window that we're looking through now is between 1.414 and 1.415. Let's take a closer look. All right, I promise this will be the closest we'll go. But now we're between 1.414 and 1.415. So we have to figure out which one is closer. So 1.414 and 1.415. And we're trying to see is 1.999396 closer to 2 or 2.002225 closer to 2. Let's subtract. Looking at this, we can tell that 1.999396 is closer to 2. So we're going to be closer to 1.414. So we're going to look at all the values between 1.414 and the halfway mark. So I'm going to start with 1.414 and do 1.4141, 1.4142, 1.4143, 1.4144, and 1.4145. And you guessed it, we need to compare the radicand values, so we need to square all of these numbers. We've hit a 2, so we can stop. The radicand value of 2 is between 1.99999 and 2.000812025. So now we know that the square root of 2 is between 1.4142 and 1.4143. So if we were to keep going, we won't. The approximate square root of 2 would be 1.4142 something. So we've estimated the square root of 2 out to 4 decimal places, which isn't bad by hand. But you can kind of see we should have some serious appreciation for our calculators. So that brings us to our final statement. The square root of 2 is approximately 1.4142 out to 4 decimal places. You can keep going. I'm not going to, but you can. Now let's see what the actual square root of 2 looks like when you do punch it into our calculator, just to check our work. Thanks for watching All Real Solutions. See you next time.